Year 12, just going to do a YouTube clip on compound interest. Most of you will have done this in your junior years, but I'm going to put it up because it's part of the sequences and series unit, and for the students who will be away, you might need a hand with this. So compound interest, we actually get given a formula for compound interest, and it's located here in the textbook, and you should know it, where the amount at the end, and this is the important bit, at the end is the principal times 1 plus the rate of interest to the power of n. Now this is a series. This is a series. If I was looking for an amount of money and I invested a principal amount, so at the beginning, and these are the words beginning and end that you have to be careful with. At the beginning, at A0, before I've done anything, I put in this principal amount. And after 1 year, that principal has been increased by 100 and whatever percent. So 1 plus the rate of interest. After 2 years, I take whatever was in A1 and I multiply by 1 plus R again. So I'm getting interest on the interest. After 3 years, I get that principal, the interest that it's earned, times the new rate, and it just keeps going on. So what I get is a principal, and if I go to the nth, I get 1 plus R to the n. Now, if you referred that to a series, because we're talking about the end of the year, that would be your A term, and that would be your R. And if we equate it in a series, T of n equals A R to the n minus 1, which in this case our A is P 1 plus R, and 1 plus R, because that's our R to the n minus 1, which just pops out, add the powers, P 1 plus R to the n. So it is a series, and what we're finding is the term in the series. Now, this can get a little bit harder, and there are only 2 questions in this exercise that require you to use logs. And there's an example of it here, where you have to use logs to help you solve. That's when you've got to find the time period, because the time period from the formula is up here. It's in the power, so we have to use logs to solve it. Now, there are only 2 questions, so I'd like you to have a go at them on your own. I'm pretty sure there are only 2 questions, and they're 15 and 16. We're going to do all of these questions, so I'm going to start off with some easy ones. Question 1 is too obvious, so I'm going to start with question 3. And what have we got? Now, the only thing that they're going to play around with you is the interest rate and the time period, so you need to be aware of that. So Chad Banks, in question 3, here it is. Chad Banks, $3,000 in an account that earns 5% per annum. Find the amount in the bank after 10 years. So I want to find the amount after 10 years if the interest is calculated quarterly. All right. And then if it is quartered monthly. So if I've got my amount is my principal, 1 plus the rate of interest to the n. Well, the principal doesn't change. It's 3,000. But now they're going to start playing with the time period and the rate of interest. Now, the big thing to look for here is the rate of interest is per annum. So if I start mucking around with quarterly, my rate of interest is divided by 4, because a quarter is a quarter of a year. So I'm going to have 1 Now, I've got to remember that it's 5%. So you can write that as a decimal, 0.05. You can put it over 4 because you're dividing by 4. But now, because you're doing it quarterly, your time period is multiplied by 4. So instead of being 10 years, it's 40 iterations. So you've divided the interest rate by 4 and you've multiplied the number of periods by 40. And then it's just a case of doing it on your calculator. In here, you could have written 5 over 100 and put it over 4. It doesn't matter. You still get the same answer. So what I've got, 3,000 times 1 plus 0.05 divided by 4 to the power of 40, which gives me $4,930.86. Always go to the nearest cent, please. Don't round off to the 5. And that's the answer. Pretty easy. That's 3A. Well, what did they do in 3B? They made it monthly. Got to be careful with monthly and quarterlies. There aren't 4 weeks in a month. Well, there are. There are 4 weeks in every month, but there are not exactly 4 weeks in every month, except February, and that's only 3 out of every 4 years. So here we go. Again, I like to write the formula. My principal doesn't change. Now, I wonder, is it going to be better to have more calculations or less? I think it's going to be better to have more. I think this is going to give us a slightly better answer. So the interest rate doesn't change. It's still 5%, but now we're doing it monthly, so we're dividing by 12. And my time period up here, 10 years, 10 12s, 120. And I can just backtrack on my calculator now. I don't have to re-put it all in. And I get 4,941. Ooh, an extra $11. Well, a little bit less because it's 3 cents. All right, so it does make better sense to have your interest calculated more often. And that's sort of an obvious statement. So these sort of questions are going to go on. They're going to say, well, find the amount. They might say, find the principal. So if I look at these questions, they're pretty standard. Find them how much money, find the amount of money will be in the bank, how much money will we have in the account at the end of that time. So they're all pretty standard. 15 years. Let's have a go at 8. That's a quarterly one. I want to try something that's a little bit different. 9's a monthly amount. Okay, let's do 10, because 10 asks for the interest. So here's question 10. What do we got? 1,400, 4 years, 6% quarterly. So the amount is the principal, 1 plus R to the n. I think it was 1,400. I think it was 6%. It was quarterly, and it was for 4 years. Let's double check all those things. 1,400, 6% quarterly, 4 years. So 1,400 times 1 plus 0.06 divided by 4 to the power of 16. So in the bank, at the end of that time period, there is $1,776.58. But the question says, what was the interest? Well, the original investment, the principal was 1,400. So the interest is 1,776.58 minus 1,400, which gives me $376.58. Beautiful. So they're pretty standard, and you should have seen these before when you did financial maths in your junior years. Again, here's an amount. Find out how much it is. Now, question 13. Here they ask us to find P. So it's lucky that we know our algebra. So we'll do 13A, and you can have a go at the other ones, and we'll see if there are any others. They say find the amount deposited 4 years ago at 5% if the current amount is $5,000. So I'm going to write my formula. Now there's 5,000 in there, so A is 5,000. P is what I want to find. The interest rate, now they've made it really easy for me because the interest has been, if they don't say anything, it's been calculated yearly. So 1 plus 5%, 0.05, to the 4. Now please remember, you can put that in your calculator and that is a number. But I'm going to just divide by it, so it's 5,000 divided by, and if you really want it, you should put it in brackets, 1 plus 0.05 to the 4. And that'll tell me what the principal is, because it's just an equation. I'll just have to divide by that number. So 5,000 divided by 1 plus 0.05 to the power of 4. And I get $4,113.51. $4,113.51. And I look at that and I think, well, that sounds right. About $4,000, 4 years, I should earn close to $1,000. Well, let's have a look at 14. How much was banked 3 years ago if the amount in the bank is $5,400 and interest is 5.8% and it's quarterly? I'd like you to go away and have a go at that if you've just been watching this video, and then come back and see if you didn't get it right, what you may have done wrong. So 14. A equals P 1 plus R to the N. Well, how much is in there? 5,400. My interest rate is 5.8. It's 3 years and it's quarterly. So my principal, that's what I've got to find, 1 plus 0.058. It's quarterly, so I'm going to divide that by 4. It's 3 years, but because it's been going through quarterly, that's going to be a 12. All I do is I divide by all of that. And I am pretty good with my calculator, so I'm just going to write 5,400 divided by, I'll put a big brace, 1 plus 0.058 over 4 to the 12, and that should give me my principal. So 5,400, 1 plus 0.58 divided by 4 to the power of 12. And I get 4,500. Well, the answer's, I have to check the answer, it's further up. $4,543.28. So $4,543.28. Now what you could do is you could put that into the equation and see if that actually gives you 5,000 when you apply the compound interest formula in a quarterly rate. But the answer's there in the back of the book. Now, these two hard questions. I want you to go and have a go at them. Look at the example that's been done. Because once we start talking about years, how long, because the n is in the power, We're going to need logs to do these. And there are only 2 questions, and I really want you to have a go at them because that's the sort of question an Extension 1 mathematics student should be able to do quite easily. So let's have a look at question 15. You go away and have a go at it yourself. Come back and check the answer. So here we go. Question 15. How many years ago was an investment made if $5,000 was invested at 6% and paid monthly and is now worth that? Well, I write my equation. A equals P 1 plus R to the n. So, how many years ago was an investment made if 5,000 was invested? So, my amount is 6352.45. 6352.45. It was 5,000. The interest rate was 6%. And it was for that many years. It's not quarterly, I don't think. No, it is. It's monthly. So they hit us with a really hard one straight up. So that's 6 over 12. And when I get my answer, and it says how many years, I'm going to get an answer in months. So just remember that. The n will be, n is in months. So when I get my answer, I'll have to remember that. So now it's an equation and I just solve it. So the first thing I do is I get rid of that 5,000. So 6352.45 over 5,000. Now that is a number, but I don't know, I'll do my calculation at the end, not now. 1 plus 0.06 over 12 to the n. Now this is where you use your change of base, or you can just take the log of both sides and then pull the n out the front. I like to use my change of base. So remember, y equals a to the x. Well, x equals log. Remember, the a always stays in the base, a, y. And then I can find anything because I can find x equals any log over any log. So the first thing I'm going to do is I'm going to use my base. So I'm going to go n equals, all right, log of all that. 1 plus 0.06 over 12 of all that. So I'll write it in parentheses. 6352.45. Now you could have already done this on your calculator and had numbers, but I really worry about getting compound rounding. So now I just go, well, it's a log of the top bit, divided by, and I'll just use ln. You can use log 6352.45. Just make sure you use parentheses over 5,000 divided by ln 1 plus 0.06 over 12. So now it becomes calculator work. But if you type that on and did that in HSC, I think I'd be giving you full marks. It shows a very good understanding. So ln 6352.45 divided by 5,000, close my bracket, divided by ln 1 plus 0.06 divided by 12. And I get 48.0001. Now I know as soon as I get that, I'm pretty much right because they've done this calculation and worked it out in reverse to get this number. And they want it to be pretty damn close to a whole number, which is 48 to 4 decimal places. And then I know, that is months. So in years, 48 divided by 12 is 4 years. Now, when I get an answer like that, I think I'm pretty close to that because it pops out as a whole number answer. So I've obviously worked it right, and it is correct in the back. Now, I want you to have a go at question 16, which is going to be the same. What tricky things do they put in there? Well, interest is paid twice a year. So be aware of that. 8%, so you're going to have to divide by 8. And when you get your answer, you're going to have to double it to get the number of years because you're going to get every 6 months. I'm going to do 17, 18, and 19 are just going which account is better. So I'm going to do 18 and then we'll finish it there and leave you with that. So 18, Hamish is given the choice of a bank account in which the interest is paid annually or quarterly. If he deposits $1,200, find the difference in the amount of interest over 3 years, 7%. Well, it's not going to be a lot. No, it's only 3 years. It's a difference of annual or quarterly, so it's only 4 times. But we'll calculate it. So 1,200, 3 years, 7%. So here's 18. Here's my formula. A equals P 1 plus R to the N. What were the amounts? 1,200, 3 years, 7%. 1,200, 3 years, 7%. And they want one paid quarterly and one paid monthly. So let's go the quarterly. The amount quarterly will be 1,200. 1 plus 0.07 over 4. 3 times 4 is 12. So 1,200 times 1 plus 0.07 divided by 4 to the power of 12. I get $1,477.73. Now, if I had that monthly, 1,200, 1 plus 0.07 over 12, 3 12s are 36. I've got that in my calculator still, so I'll just go back and I'll divide by 12 and I'll change the power to 36. And I get $1,479.51. They asked for the difference. Well, the monthly is bigger. So AM minus AQ, which is 1,479.51 minus 1,477.73. So as you can see, not a lot. So I'm minus. I've still got it in my calculator, 1,477.73. And I get $1.78, which is not right. It should be $7.68. Did I do something wrong? Did I do something wrong? 12, 3 12s are 36. Did I read the question correctly? Oh, it's annually. It's annually or quarterly. So I have to do an annual one now. So the difference there between that is only $1.78. Annually, the amount annually is 1,200. 1 plus 0.07 to the 3. 1,200 minus times 1 plus 0.07 to the 3, which is 147 0.05, and it was a disparity of annually or quarterly. So AQ, the difference, minus just annually, is 1477.73 minus 1470.05. And I get $7.68, which is the correct answer. Make sure you read the question next time. So these are all pretty easy. Please, can you get into the habit of writing your formula, then showing your substitutions? That is really important. Because you can work quickly and make a mistake, and if you haven't shown your substitution, markers won't know what you've done. So show your substitutions and then arrive at your answer. Remember, the hardest one is question 15 and 16. Good luck.